So in this video, we're going to talk about custom exceptions, and this allows you to define your own exceptions that may happen in your code. So to be clear, why would you ever want to do this? Well, we've talked about in some of the previous videos on exceptions that sometimes you may have an actual error that is unrecoverable, like trying to divide by 0, and there's already an exception built into Java for that. And then we talked about you can just throw an exception, and it's a generic exception that has a string in it anytime that you want to. But most of the time, the generic exceptions is going to get very confusing. So think about this. If you had a bank account, we've already talked about in a previous video how you could run the bank account out of money. You could have an insufficient funds problem. But the other problem that you could have is the bank account could get closed. So at any point you can go into the bank and you can close the account. At that point, trying to do a withdrawal should also throw an error. So doing a withdrawal could cause two different exceptions. One of them would be the account is closed, and another one is you can't do that because you don't have enough money, which I think we're all familiar with these days. But anyway, the important part of this is it would be helpful to be able to understand which error occurred. And if both of those throw exception, then that's not very helpful to somebody who's using your class or your code to be able to tell what actual problem they have encountered here. So that's why you might want to be able to define your own version of an exception. So to be clear, there are the built-in ones in Java and in C#, and we've talked about those in previous videos, and you can go back and look at those. So there's, array out of bounds or index out of bounds an array. There is you've tried to divide by 0. There is you've tried to open a file that doesn't exist. There's a whole bunch of exceptions that are already defined. This is when you want something that is your own and is typically going to be something that is not a problem like a divide by 0, but it's more of a logic problem in your code, something that you don't want them to allow the user to be able to do. All right, so when you define a class that is an exception, you're going to do it something like this. So you're going to define a new class, and that's what's happening here on this code. You're going to say class insufficient funds exception, and it is always going to extend exception. So in both Java and C#, you are going to extend exception. And then after that, you can build methods in that class just like anything else, just like any other class that you might deal with. So for example, you might have a constructor that takes nothing, which is what's happening here, and then you may have a different constructor which takes in a string, and then you may call your parent with that message that you got, the message being the variable here, and that would have the effect of it then throwing an exception with that particular message. But it knows that this particular exception is an insufficient funds exception as opposed to what we saw on the previous type of exceptions, which was a regular, just everyday exception that's quite different. All right, so let's move on and take a look at the next slide if we can. Come on, you can do it. Okay, so that's the Java version of that. The C# version is going to be pretty much the same, but of course you'll have your own changes in here because you have the way that you extend a class is going to be done the same way that you always extend a class. So instead of the extend keyword, it's going to be a colon, but the class that you're extending is always going to be exception. It's the same in C# and Java. And then the only thing that's different here is that the way that you call the parent is you say base, and you pass it the message, and that happens as part of the header. All right, so that's how you define a new exception. So let's take a look at an example where that might be useful. So we'll start off in C#. So in one of the previous videos, I created a bank class, and just to quickly recap, the bank class has an account number, and it has a balance, and I've added a new thing to it, which is a Boolean, which determines whether it's open or not. And then when the bank account is opened, so when the constructor is run, it gives it a new account number, and that makes sense. And then we set the balance to 0, and we set the account to open. So the new thing that I'm going to add to this is down at the bottom here, I'm going to add a new method called close account, which takes no parameters and simply sets open to false. All right, so now every time we do a operation on the account, we can check, is the account actually open? And so what's happening here is in the deposit, if you try to do a deposit, the first thing that it does is it says, if open is false, then throw account closed as an exception. So what is account closed? Well, that's a new class that I defined up here. So class account closed extends exception, and it has a constructor which takes in a string and it simply calls its parent. But so it's the same as me saying new exception, except the difference here is that it's a new class. So I can check to see which type of exception happened. I can tell that it's an account closed as opposed to it just being a generic exception. So I'm doing the same block of code inside each one of the methods. So if you tried to make a deposit, I check to see if we're open. If you try to make a withdrawal, I check to see if we're open. If you ask for the account balance, I check to see if we're open. And in any of those cases, if it's false, I'm going to throw the exception account closed. So down in my main here, I create a new bank and I make a deposit of $100. I print that out. And now just to show how things are going, I'm going to do this account closed. I try to do a withdrawal of $100, and if that has a thing, then it causes an exception, etc. All right, but down here I'm going to say close the account, and now I'm going to try and check the balance. So I'm wrapping this in a try, and I'm specifically trying to catch account closed, in which case I will print out account closed. And as you can see, when I run this code, the balance is now 125, account closed balance was 25 cents, and that's because it succeeded in doing the withdrawal of 100, and then when it closed the account, that worked, no problem there. But then as soon as I tried to do a check balance, when it tried to execute check balance first started off and said, is open currently false? And it threw account closed, which is that new class that I created up above. And since I caught account closed down here, I get this print statement. All right. Had I not done this catch down here, and had I not put that in the try block, so for example, if I comment all this out and down below it, I just do the same line without the try catch around it, what is happening? Somehow I deleted that. Okay, so if I try to just print the balance, you're going to see that the program is going to crash, and that's simply because there's an unhandled exception, which is account closed. But that's really important that you can see that the exception that happened is account closed, it's not exception. So somebody using this class would be very easily able to tell what's going on, that the account is closed as opposed to an insufficient funds problem, as opposed to I tried to divide by 0, as opposed to 500 other things that could have gone wrong. So this is the reason why you might write a custom exception. That was the Java code. Of course, that was the C# code. Of course, in the Java code, things are going to be ever so slightly different, and so we're going to take a look at that as well here. So the definition of my account closed exception, really not that different. Class account close extends exception, and I have a constructor which calls the parent passing it the message. That part's real simple and real similar. But down over here in my bank class, I still have my Boolean for open, and I still set it to true when it is opened, and I still have an account close method down here that sets it to false. The thing that is different is every method where I'm checking if it's open, which is the same code that I used in C#, at the beginning of every method I say, if open is false, then throw new account closed, balance was balance. But every method that I do that in now must be declared as throwing account closed. So at the top I will say throws account closed. Public void deposit double amount throws account closed. And I'm just going to move this window over so you can see that that's actually all in one line. It is in the header of each of the methods. The withdrawal method is even a little bit more complicated because remember we dealt with the circumstance where they had too little money and we threw an exception in that circumstance. They were trying to withdraw and they don't have enough money. So this method actually throws two different exceptions. If the account is closed, then it throws account closed. If they try to withdraw too much money, then it throws a generic exception with the message insufficient funds. That's probably not great. We should probably have another custom class called insufficient funds, and that's what should be happening. But if you see in the header here, public void withdrawal, double amount throws exception, comma, account closed, because it is throwing two different exceptions. And then our check balance also throws account closed. So you can see that that all got added in there. And now I'm going to go take a look at the main method in Java. And so things again are ever so slightly different here because what I did was I just wrapped all of the code in one try block. I said try doing the deposit and then the balance check and then the withdrawal and then the actual account closed and then try to check the balance. And then I just put a catch for account closed and a catch for exception down below. I'm cheating ever so slightly here, and the Java folks are probably going to see that. But if I run this code, we will get the same output as the C# code, which is this will succeed, no problem. This will succeed, no problem. This succeeds because I'm only withdrawing $100. That's the cheaty part. This will close the account successfully, and then at this point, we will throw an exception which will stop the execution of this try block, and it will go down, and we will get this printout of account is closed, which is what we get. Why am I saying this is cheating a little bit? Well, if I go up here and I change this to 200, the output is going to be quite different. So what's going to happen is, at the moment it gets to this line, an exception is going to be thrown for insufficient funds. And remember, and this is an important point for both the Java and the C# folks, as soon as an exception is thrown in a try block, all of the code down below it is never going to happen. So this is going to cause an insufficient funds error, which is going to print out that, and then the code exits because it'll move on to after the catch block, of which there is nothing down there. So it never even tries to close the account, which may not be what you want. And so just keep that in mind. You could obviously break this into two separate try-catch blocks if that's what you wanted to do. I just wanted to show the difference between the two. These are in Replit. They are CSE 1322 custom exceptions -Java and -C#, so you guys are welcome to get them. All right, so there's one final topic that I need to talk about, and that is the idea of a checked and an unchecked exception. So in Java, there are two types of exceptions. This is Java specific. There'll be a C# specific thing in just a moment, so bear with me. In Java, anything that inherits from either error or runtime exception is going to trigger what's called an unchecked exception. And what that means is the compiler is not going to look for this problem. So anything that's in error or runtime exception is going to happen, and you're not going to get a compile error from it. And if you think about that, that has to be true, because some exceptions, like divide by 0, the compiler will not know that answer. If you think back to an example from a couple of videos ago where I let the user enter in some numbers and then I was going to average them or sum them, if they enter in no numbers and I try to divide by the number of numbers they entered, which was 0, that's going to cause a divide by 0. But there's no way for the compiler to know that. The compiler compiles the code at the beginning. It has no understanding what the end user is going to put in. So in Java, these are considered unchecked exceptions. And the other type of exceptions are checked exceptions. Anything that inherits from exception instead of runtime exception, so anything that's not in the above category is considered checked. So when I created my account closed exception, you note that I extended exceptions, and as a result, it is inherently a checked exception. So in Java, if I did not put a try-catch block around every one of my calls that could throw account closed, it will error. The compiler will not allow me to run the code. It is checked at compile time. And that's why I mentioned when we were looking at the Java code that I ended up having to do a lot more work inside of the Java side than I did inside of the C#. In each one of the methods, I had to specify what I was throwing, and the moment that I do that, the compiler can actually check. So in a way, Java is more specific about the exceptions. If you say that it can throw it, then you better catch it. All custom exceptions can only be thrown by you. There's no way that Java will ever throw account closed magically by itself. You will be the one throwing it because it's a custom exception. Java can choose to throw a divide by 0 because that is something that can happen in the code. But it will never throw account closed unless you specifically write code that says, now I would like you to throw account closed. So if you're going to do that, you have to declare that the method is possibly going to throw that, and then in your main method, anytime that you use that method, you have to have a try-catch block around it, otherwise the compiler will fail, and it will not allow you to run it. So that is the idea of a checked exception versus an unchecked exception. Checked exceptions, as the name implies, are checked by the compiler. You must have try-catch block around anything that has a checked exception. Anything that extends exception, which is anything you write custom, and also the other ones that are in the chart that are inherently underneath it, such as IO exception, file not found, socket exception, all of those will also be checked. You will note that runtime exception is a child of exception. All of those are not checked. That's just a weird quirk. All right, and that's because, as I said up here, runtime exception is not checked. All right, so what kind of exception are we getting here? Well, we can see that this is a compiled error. So it is not letting me move on because in this case, I'm trying to run system.in.read, and that is one that very specifically has a exception ability. It will throw an exception under certain types of inputs, and so it's an IO exception, and that is a caught exception. So the fact that I didn't catch it, that has to be in a try catch block, otherwise it won't let me compile. And then over here we have a division by zero problem. You'll note that this compiled and it ran, but in the middle of running it, we got a divide by zero error. So that's what's going on there. So checked versus unchecked in Java is what we just talked about. Now, let me talk to my C# folks. There are this is different than the Java version, but there is also the concept of a checked and an unchecked exception in C#. So checked, the common example that you would run into here is that if you're dealing with an integer, you can specify that you want it to be checked. So let's take a look at this example here. So I'm setting a value on an integer to this huge number, 2, 1, 4, 7, 4, whatever. All right, and that happens to be very close to the upper bound of what an integer can handle. And as you probably remember, integers go from -2 billion to +2 billion, but very specifically, it's this number is the upper bound. So if I then try to add 10 to that, what do I get? And the answer is, if I print out the value in this print line down here, I'm going to get this really weird number, -2147, blah, 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 blah. So to be clear, I started off with this big number, I added 10 to it, and somehow I ended up with this massively negative number. Well, that's because you wrapped over the maximum number that an integer can handle. And C# allows you to do that, as does Java, because that's kind of on you. You declared it as an integer, and then you put something in there that was too big. So this inherently is not checked in C#. If you want this to be checked, then you use the keyword checked. Anytime that you're dealing with a number that could overflow the integer bound inside of C#, you can simply put the word checked on front of it, and if it overflows, this will cause an overflow exception. It will actually throw an exception that you can now catch and do something intelligent with, as opposed to it just randomly ending up with this huge negative number, which would be very bad if you had a lot of money in you have $2 billion in your checking account and you put $10 more in, and suddenly you have a balance of -2 billion. Your customers are not going to be very happy with that. So make sure you check your integer values, and that's how you do it with checked. Really only have to do that if you're getting to really large numbers. All right, so that is the end of the lecture on custom exceptions in C# and